this is Saurabh Jotwani and I welcome you all to my YouTube channel Believe in Electronics. So today I am going to teach you about the basics of electronics. Before starting this session, a very important and a very basic question comes in mind or commonly asked in many of the interviews, generally when you are applying for a core industry, is that what's the major difference between electrical engineering and electronics engineering, or the electrical circuits and the electronic circuits. As this question arises due to a similar type of pronunciation between them, or that sounds like so familiar, but no doubt these both are different in their own way. But there is one similar thing between both of these, is that both deals with the moving of electricity around the circuit to give power to the useful products. Okay, so now we will talk about the difference between both of these fields. Okay, so first we will talk about the electrical engineering. Electrical engineering is all about the transmission and distribution of electrical energy. The transmission and the distribution of the electrical energy. However, the main objective of this field is to provide electrical power as a source of energy in different ways. This field also describes the uses of currents, whether it can be a DC current or it can be an AC current. It can be a DC or the direct current, or it can be an AC current. And it also deals with the voltages and the magnetic fields as well. The voltages and the magnetic fields as well. Okay, so this is all about the electrical engineering. Now we will talk about the electronic engineering. Electronics engineering is the study of flow of electrons, and the different types of semiconductor devices also comes under the electronics engineering, and the different types of ICs also comes under the electronics engineering. ICs is nothing but the integrated circuits. First, the flow of electrons. Second, the semiconductor devices. And third one, the integrated circuits, which is nothing but ICs. So talking about the semiconductor devices, we can say that in a very simpler way that semiconductor is nothing but a device that is neither a good conductor nor a good insulator. That's why it is a semiconductor. So various types of devices comes under semiconductor devices, such as the transistors, the diodes, and you can also say the ICs as well. So this is all about the electronics engineering, then the flow of electrons and the semiconductor devices and ICs, the designing of the circuits, and all that comes under the electronics engineering. So we will talk about all these topics in brief in my upcoming sessions. So for now, we will talk about the difference between the electrical circuits or devices and the electronic circuits or devices. Okay, so now we will talk about that how the electronic circuits or devices are different from electrical circuits or devices. A very simple and a major difference between both the electronic circuits and the electrical circuits is that electronic circuits are capable to make decisions, that they can perform a task on the basis of given instructions, that they are capable to make decisions. And we can also say that the electronic circuits are designed with the help of the semiconductor devices that we have discussed earlier. And now comes the electrical devices. Electrical devices are not capable of making decisions. They just simply powers the machines with the help of electricity. Not capable. So, for example, a microwave oven oftenly bleeps a sound when it has finished cooking to inform the user that his or her food is ready. So, behind that bleep sound, there is some sort of electronic circuitry which is designed in such a manner that is capable of taking decisions of that bleep sound. So, in this manner, we can say that the electrical devices are different from electronic devices. So this is all about the electronic devices or circuits and the electrical devices and circuits. Okay, so now we will focus on our today's topic, the basics of electronics, which is nothing but the foundation of electronics, because without the knowledge of these things, it's impossible to go further in electronics. As you can also compare this, that to build a building, it's impossible to go further without the foundation, as it's a very important and a major part. So, firstly we will talk about the voltage and current, a very important key part in electronics, as without these no operations can be performed. So, first we will talk about the voltage. Voltage is nothing but the EMF generated or produced, or we can also say that EMF as the electromotive force generated or produced, and its SI unit is volts, which can be also denoted as small v. Okay, so now to understand that what is voltage, first we will consider 2 points. First, which is kept at a positive potential, and the second which is kept at a negative potential. Then we will connect these 2 points with an electronic component. It can be any electronic component, and we will join like this. So voltage between these 2 points is the cost in energy, or we can say that the work done between these 2 points. If we apply a voltage between these 2 points, then the work is done between these 2 points. Work done means that in a very simpler way we can say that the voltage, if we apply a voltage between these 2 points, it pushes the electrons to flow in a particular direction. It gives the energy to the electrons to flow in a particular direction. So now we will talk about a practical example. We will take a practical example like 1 joule of work is done in moving 1 coulomb of charge. Charge is nothing but the positive potential or the negative potential. That is the electric charge. So now what is joule? Joule is the unit of energy. And what is coulomb? Coulomb is nothing but the unit of electric charge. Coulomb is the unit of electric charge. Okay, so now we can say that 1 coulomb of electric charge is equal to 6 into 10 to the power 18 electrons. This is the value of 1 coulomb. 1 coulomb consists of 6 into 10 to the power 18 electrons. This means that we can say that 1 joule of energy is required to move 6 into 10 to the power 18 electrons. One joule of energy or 1 joule of work is done to move 6 into 10 to the power 18 electrons when it is kept, when the potentials are kept at 1 volt. This is the positive potential and this is the negative potential, and the potential difference between this is 1 volt. So if we consider a potential difference of 1 volt, then 1 coulomb, then 1 joule of energy is required to move 6 into 10 to the power 18 electrons. So this is all about the voltage. Okay, so now comes the current. Current is nothing but the rate of flow of electric charge. Voltages only let the charges to move in a particular direction, but current tells the rate of that flow. So the current, which is nothing but the rate of flow of electric charge, and its unit is ampere, which can be also denoted as capital A. So 1 ampere of current is equal to 1 coulomb of electric charge per second. As we have discussed earlier that 1 coulomb of electric charge is equal to 6 into 10 to the power 18 electrons. So we can say that 1 ampere of current is equal to 6 into 10 to the power 18 electrons, flowing through a conductor in 1 second. So if we are considering 1 ampere of current, then in 1 ampere of current, 6 into 10 to the power 18 electrons moves in 1 second. So the current moves from positive potential to negative potential, and the electrons moves from negative potential to positive potential. Current moves from positive to negative, and electrons moves from negative to positive potential. In the opposite direction the current is flowing. So current flows through devices or circuits, but the voltages are applied between the 2 points. We can't say that the voltage flowing through a device or a circuit, but we can say that the current is flowing through a device or a circuit. As the voltages are applied between the 2 points, then the first point we consider as the positive potential and the second is considered as the negative potential. So talking about the currents, these only flows through a device or a circuit. So at the last we will say that the voltages are nothing but the work done between the 2 points, one which is kept at a positive potential and the another which is kept at a negative potential, and the current is nothing but that is flowing through a device, or the rate of which is telling the rate of flow of electric charge. Okay, so current flows through a device, but voltages are applied between the 2 points. We can't say that the voltages flowing the voltage flowing through a device or a circuit, but we can say that the voltage at a point in a circuit, which means that the voltage at that point and the ground or the negative potential. So talking about the currents, we can say that current flowing through a device or a circuit, and we can't say that the voltage is flowing through a device or a circuit. We generally say that the voltage at a point in a circuit or the voltage between these 2 points. So at the end we say that the voltages are generated by doing work on charges and the currents are generated by applying voltages. So I make sure that I let you know more about the basics of electronics in my upcoming sessions, but for that please do not forget to like and subscribe.